For the given uniform square lamina ABCD, whose center is at O, right? Some things are missing. This is O and this is E, right? Now let us see the options. IAC is equals to root 2 IAF. So basically it is talking about majorly moment of inertia about AC and moment of inertia about EF, right? So basically we have to calculate these two and what is the relation between them. For a square lamina, what is the formula? First of all, for moment of inertia, you might have read for a square lamina, moment of inertia about an axis passing through O and perpendicular to the plane, right? Perpendicular to the plane of the paper, IO is given by m a square by 6, right? This is the basic formula. Now this question is basically a theoretical question, although a lot of students might be thinking how to solve this, but even if I was doing my paper, this was just a theoretical question. I'll just tell you how, right? IO is given by ma square by 6, is that right? So basically this is like IO is about this point O and perpendicular to the plane of the square lamina, right? Now we have to calculate IAC and IEF, right? Now these two axes are in the plane. Now for planar bodies, we can make use of perpendicular axis theorem. Is that right? We know that for perpendicular axis theorem, perpendicular axis theorem is actually applicable for planar bodies only, where we can say IZ will be equal to IX plus IY, where the planar body should be in the XY plane, right? So that means IZ will be equal to IX plus IY, right? Now what happens is these two are in plane, basically the planar body is in XY plane. That means if I talk about AC and BD, right? If I talk about AC and BD, so what will happen? I0, I can write that as I0 will be equal to IAC plus IBD. Is that right? This would be absolutely correct. So that means IAC will be equal to what? I0 by 2, because these two are symmetrical, very much symmetrical. Is that right? Because AC and BD means the same thing. So that means IAC will be equal to what? IBD. Absolutely correct, right? So that means IAC will be equal to I0 by 2. Now I can take another axis as perpendicular to EF. Let us suppose mark them as MN. Now I can also write from the same perpendicular axis theorem, I can write that I0 will be equal to IMN plus IEF, right? And also these two will be equal because these are planar bodies and they are symmetrical. So that means IEF will be equal to IMN, or IEF I can write it as I0 by 2. So IEF comes out to be I0 by 2. So that means IAC is also the same. So that means IAC will be equal to what? IEF, right? So you do not solve anything else. If it is a planar body, any axis passing through it and any axis at an angle in the same plane, they will be having the same moment of inertia. Is that right? So that means we can mark the option as D.